When two or more gears are meshed together, they form a gear train. A gear train can be used to change the speed or the torque of a mechanism. These mating gears turn in opposite directions because they are meshed together. The gear ratio of these gears is 1:1 because they have the same number of teeth. Because the gear ratio is only 1:1, the speed and the torque do not change. In this case, however, the speed and the torque do change. The driver gear on the left has 60 teeth, and the driven gear on the right only has 12 teeth. This means the gear ratio is 1:5. For every one whole turn of the driver gear on the left, the driven gear on the right turns 5 times. This would be a good gear ratio if you are trying to increase the speed and decrease the torque. If you want to gear the mechanism for more torque than speed, you can flip the gears and have the gear on the right, which has only 12 teeth, be the driver gear, and have the gear on the left, which has 60 teeth, be the driven gear. This gives you a gear ratio of 5:1, and for every 5 times you turn the 12-tooth gear, which is the driver gear, the 60-tooth gear will turn only once. Idler gears are used to keep the direction of motion between the driver gear and a driven gear constant. Normally, two mating gears will turn in opposite directions, but if you have an idler gear in between them, the driver gear and the driven gear will turn in the same direction. Idler gears do not affect the gear ratio. Even though the idler gear in this situation only has 12 teeth, and the driven and the driver gears both have 84 teeth, the gear ratio is still 1:1. Moving on from simple gear trains, there are also mechanisms called complex gear trains. With complex gear trains, there can be more than one gear on the same axle. For all the gears on the same axle, they all turn in the same direction and they turn at the same speed. This situation is more complex, so we will label the gears. To find the overall gear ratio, you can look at gears A and B as one simple gear train, and then look at C and D as a separate individual gear train, and then multiply the two gear ratios together to get the overall gear ratio. So gear A, which is a 12-tooth, is connected to gear B, which is a 84-tooth, so that gives you a gear ratio of 7:1. And then gear C is a 36-tooth connected to D, which is a 84-tooth, and that gives you a gear ratio of 2 1/3 to 1. So if you multiply 2 1/3 to 1 by 7, you get 16 1/3, and that's the overall gear ratio, 16 1/3 to 1.